So let's talk about the notation for limits. So f of x is a function where I am trying to think about limits. I'll say that x is approaching some coordinate a. I can fill that in later. And I'm also going to say that the limit of this function does exist, like some of the previous examples we've seen, and that the limit is going to be equal to some real number that I will call capital L. And the way I put that all together in my notation is this equation right here. So reading this out loud, I would say the limit of f of x as x tends to a is L. So this is my notation that's built up using equations, the same as we communicate a lot of other mathematical ideas. I want to point out that there are three major pieces of information here. So I need to say what function I'm working with. Right now, I've just given it the name f of x. I might also write out the formula for that function. I need to tell you what x coordinate we're getting close to. So I need to have that a there. And finally, if the limit does exist, I need to have the value of that limit. So I need to have that L. I'm looking through for all three of those pieces in my equation. Let's see this with some examples. Some of these are functions from my previous videos. Now, I claim that the limit of the sine function, sine of x, as x approaches 0, is going to be equal to 0. I didn't do this one in my previous video, but it's the same intuition as with the polynomial case. You just follow the y coordinates and they will get closer and closer and closer to 0. The second one of these is my rational function. The limit of the function sine of 3x divided by x as x approaches 0 will equal 3. Even though this formula does not allow me to just plug in x equals 0. I can't evaluate it algebraically, it's undefined. But the limit lets me say that that function really is getting closer and closer and closer to a y coordinate of 3. This is the notation that I use to write that down. My third one here is a bit of a curveball. I'm calculating the limit of the cosine of 1 divided by x. I'm taking the limit as x approaches the coordinate 2 divided by pi. So again, I haven't graphed this one out, but I would see that I'm getting closer and closer and closer to a y coordinate of 0, because as x approaches 2 divided by pi, well, 1 divided by x is going to get closer and closer and closer to pi divided by 2. And as we get closer and closer and closer to pi divided by 2, the cosine is going to get closer and closer and closer to 0. Now, I picked this because cosine of 1 on x is one of my tricky functions. We looked at what happens as x approaches 0 for that cosine function, and we said that it does not exist. So when that happens, I'm just going to write out the sentence, the limit of cosine 1 divided by x as x approaches 0 does not exist. Now, there was those piecewise functions that were doing different things from the left and from the right. And that's still valuable information, even though the limit doesn't exist as a singular coordinate. So we're going to modify the limit notation a little bit in those situations. And the way that we do that is by putting either a minus sign or a plus sign as a superscript on the value for A. So on the destination for X. We use the minus sign to mean coming from the left. So the negative half of the x-axis is on the left. And we use the positive sign for coming in from the right because the positive half of the x-axis is on the right. It's just, a traditional math thing. So for piecewise functions, I can say things about the limit on the left side and the limit on the right side. And I might ask myself, okay, do those limits still exist even if the two-sided limit does not? So I can talk about a one-sided limit where maybe the limit of f of x as x approaches 0 from the left is positive 1. Or I could say that the limit of f of x as x approaches 0 from the right is positive 2. So those are how I would read these equations out loud. And you can notice that I have actually borrowed my arrow right here from the limit symbol. So if you're writing this out, you can just write x right arrow 0 to mean as x approaches 0. That's totally fine. We use a lot of shorthand in math. Save ourselves some time. Now, this function is the piecewise function that I had on my graph in the previous videos. And we saw that that two-sided limit did not exist. I didn't use the phrase two-sided, but I said because the function can't make up its mind, that limit doesn't exist. So if I was going to write this up formally, I would write the two-sided limit of f of x as x approaches 0 does not exist.